Hi, Assalamualaikum and good morning to Dr. and my fellow friends. We are from Group 5. We want to present the analysis of the stock price behavior of Netflix. So let's get started.
My name is Mke3507. Firstly, I will show you the graph that has been plotted for Netflix company based on closing price from January 2020 until December 2020. As you can see, the overall trend of the year is uptrend. The Netflix share price during the study period shows two different states, which are increase and decrease. The probability of occurrence of these two different states can be obtained from the initial state vector. The initial state vector is denoted by eta 0 and given by eta 0 equals to eta 1 and eta 2, where eta 1 and eta 2 provide the probability that Netflix stock price increase and decrease respectively. Then eta 1 is equals to 0.4841 after we sum up the value of decrease and remain negative days, which are 70 plus 52 divided by the total days, which is 252. Then after we add 69 and 61, which are the increase and remain positive days, divide by 252, we get eta 2, which is equals to 0.5159. Hence, the initial state vector for Netflix stock price is eta 0 equals to 0.4841 and 0.5159. After we calculate according to the value of each row and column that we have obtained, then we divide the value by the total value of the row. We will get the transition probability matrix. To be clear, in this diagram shows that there are two possible states, which is D for decrease and U for increase. And the arrows from each state to other state shows the transition probabilities value. So for D to D state, the transition probability is 0.4298. Then for D to U state, the value is 0.5702. As the transition probabilities for the U to D state and U to U state are 0.5385 and 0.4615 respectively.
Next, for the task 2, we need to find the long-term behavior of an FLX share price. The long-term behavior can be determined by using T-step transition probability matrix, which is the probability of micro change in state J at time t given that it is in state I at time 0 is equal to the probability it is in state J at time t plus n that it is in state I at time n is denoted as P power of t ij for any n. P power of t ij is called the T-step probability of a transition from state I to state J. We also know that the transition matrix P follow the following probability, which is P power of t is equal to P power of t minus 1 times P. It is used to find the higher order of transition probability matrix. The long-term behavior of an FLX stock price is calculated as shown in the slide. In the result, we can see that after matrix P4, the matrix approaches to steady state and remain unchanged. This is because when the number of steps increase, the matrix converges to limiting transition probability matrix. It provides steady state probability in different states in the future. From the transition probability matrix, we can see that the probability an FLX stock price decrease in the future irrespective to its initial state, increase or decrease is 0.4857. And we can see that the probability an FLX increase in near future irrespective to initial state, either increase or decrease is 0.5143.
Hi, my name is Mke3507 and I want to present expected number of visits of different states. The expected number of visits made by change from state I to state J is given by min IJN equal to E and IJN, where an IJN is the state denoted as the number of visits from state I to state J in n steps. So the expected number of visits to the state J throughout the lifetime the chain is min IJN equal to limit E and IJN. Here, the net fleet of the stock price reach the expected number of visits to a particular state for 4 trading days in different as a matrix. The matrix shows if the net fleet stock price starts from increasing state for net fleet stock price made to increasing state out of 4 trading days is 2.1076 and to decreasing state is 1.8924. If the Netflix stock price start from decreasing state, the expected number of visits the chains to increasing the state is 2.0096, to decreasing state is 1.9904.
Assalamualaikum and hello everyone. I'm Nurul Wazira binti Abdul Rashid as 59409. Next, I will explain about the expected first switching time of different states, which is also known as mean hitting times. The formula used to calculate the expected first switching time of different state is 1 plus the sum of PIK MKJ, where PIK is the probability from state I to state K that can be get from the transition matrix and MKJ is the time taken. First, we calculate the expected first switching time from state D to state U. It is equal to 1 plus the probability of state D to state D, which is 0.4298 MDU. So the expected first switching time from state D to state U is 1.7538. Next, we calculate the expected first switching time from state U to state D. It is equal to 1 plus the probability of state U to state U, which is 0.4615 MUD. The expected first switching time from state U to state D is 1.857.
Hi, my name is Nur Haizatu Haida. Metric numbers S60339. I will explain about identify whether the Markov chain is irreducible or aperiodic. Irreducibility means you can go from any state to any other state in a finite number of steps. The Markov chain or transition metric P is said to be irreducible if the state space is finite and all states communicate. Then that is the Markov chain is irreducible. Then in the long run, regardless of initial condition, the Markov chain must settle into a steady state. For example, let U and D be two distinct states of a Markov chain. If there is some positive probability for the process to go from state U to state D, whatever be the number of steps such as 1, 2, 3, then we can say that state D is accessible from state U. We express this as U approach to D. In terms of probability, it is expressed as a state D is accessible from state U if there exists an integer m greater than 0 such that PMUD greater than 0. So do D approach to U. Now, if both are true, then we say that the states U and D communicate with each other and is expressed as U and D is approaching each other. In terms of probability, this means that there exist two integers m greater than 0 and greater than 0 such that PMUD greater than 0 and P and DU greater than 0. In this case, the Markov chain or transition metric P is irreducible. Besides irreducibility, we need a second property of the transition probabilities, which is aperiodicity. In this case, it is aperiodic because it has self-loop. For a self-loop state, it is possible to return to the state in 1, 2, 3, 4 steps. The condition must be GCD, which is great common divisor equals to 1, so the state is certainly aperiodic. For example, imagine you are in state U. The number of states you have to visit before you visit U again could be 1, 2, 3, etc. It will happen, so probability is greater than 0. So the GCD of all possible number of visits which could occur before you visit U again is 1. This means that U is aperiodic. Same applies to D.
I will explain to you our 3B, which is we need to find the limiting distribution and the stationary distribution for this chain. We need to find our stationary distribution by from our transition matrix that we get, which is we know that pi equal to pi transition matrix by multiply pi 0 pi 1 with our transition matrix. Then we will rewrite, and from the result of our multiplication we will get 0.4298 times pi 0 plus 0.5385 pi 1 equal to pi 0. Then, after we rewrite again our equation, we will get pi 1 equal to 1.0589 pi 0, which is become our second equation. Our first equation is, we know that pi 0 plus pi 1 equal to 1. Then, our third equation become pi 0 equal to 1 minus pi 1 from our first equation. Then, we will substitute the second equation into our third equation. We become pi 0 equal to 1 minus 1.0589 pi 0. Then we will get pi 0 equal to 0.4857. Then as we know that pi 0 equal to 0.4857, then we will substitute our pi 0 into our second equation, which is pi 1 equal to 1.0589 times 0.4857. Then we will get pi 1 equal to 0.5143. Then the answer that we will get is pi equal to 0.4857, 0.5143. Then for limiting distribution, from the above stationary distribution is a limiting distribution because the chain is aperiodic and irreducible. Thank you.